Welcome to the event. I'm actually pleased to be part of this community today. Really talk about digital twins for smart cities and the work that we're doing with Azure Digital Twins. But I'm really excited to learn more also from the community. So I'm Miriam Berhane Russom. I'm part of the Azure IoT team. Justin mentioned a lot of times Azure IoT. She said that Azure Maps would do everything that Azure IoT would ask, and that's pretty much true. There's pretty much, obviously, location is so important for anything that has to do with IoT and more. I am in a team specifically that's called Smart Places and Energy. And so our team really focuses on anything that has to do with buildings, campuses, stadiums, cities, and infrastructure, and with a very special focus on energy and sustainability. And so my focus is on smart cities. Obviously, cities, as everything else, have been going massive transformation and innovation in the past years by really using technology. There are various reports that population increase in cities is just going to increase, keep growing. Maybe the most relevant one is the UN estimates. Well, that might change according to the current pandemic or not. We'll see what happens. But yeah, cities have been facing, NCD leaders really pressure from outdated infrastructure, from increased expectation of citizens and other businesses and organizations that actually live and coexist and operate within the city space. And so those are just some examples, right? We all expect right now to know when our bus is going to come through some sort of an information. So there's some sort of tracking in the buses that's happening with where pretty much location. We want to know that information. If safety is so important to the point that there are probably cameras in the urban spaces that are probably monitoring whether it's anything that might be suspicious, or just even things like people flow and sudden increases in crowd, obviously by looking at privacy and doing it in such a way that doesn't reveal any PII, but it could be also for traffic information and traffic flow, right? And better manage that. Waste, again, waste and how if waste bins are full in a city, and so such a way they could be dispatched promptly. Some cities face the challenge of their waste bins actually get full pretty often, to the point that they might be emanating bad smell and odors in the surrounding area, and others probably they will get full once a week. And so really dispatching trucks that could offload this in a timely manner, but also in a way that it's efficient to the city becomes very important. And so we start seeing all these IoT devices and sensors that start getting embedded in a lot of different devices and assets, right? And that are transmitting information. So if we really look at what's been happening over the past years, we've been seeing really like this, what we called everything started becoming intelligent. If you see with IoT devices and sensors, they started being embedded everywhere. Obviously, there are streetlights that are smart right now. You see buildings are full of sensors and devices that maybe are monitoring occupancy or air quality, or just the temperature within a building. So then probably HVAC systems could be managed in a more intelligent way, stadiums and so on and so forth. And so I really love this picture in a way, because it kind of shows that unlike an urban space in a way, and different type of domains or industries, whether those are retail spaces, whether those are commercial buildings or offices, whether those are stadiums or hospitals or factory floors, as well as different type of infrastructure like energy grid. You see a massive transformation happening. And so yes, it's almost like each domain has been adding intelligence to assets. There's no question that IoT is just at the forefront of digital transformation, what we call digital transformation, and really being able to manage assets more efficiently. But what we are really seeing is this emerging what we call intelligent environments. So in a way, connecting assets by itself brings a lot of optimizations and efficiencies, but what businesses and organizations are really looking in really understand the entire environment, not just the specific assets. So for example, a street light, right? It's in a street. It can manage a street light by itself and, have some sensors that could turn on and turn off the lights according maybe to some schedules or according to some environmental conditions like the snow, sun. Oh, okay, there's sun, there's light versus not. But if you start knowing the context in which the street light is placed, for example, is it close to trees? Is it in a park? Is there a school near a park? And all of those things, the type of decision that you start making on those street lights and the type of light that you want, it starts becoming different. And so as you bring all this type of information together and you start understanding and having a representation of the environment, all this information that comes becomes really powerful and allows the creation of additional optimizations or experiences really for the people also that live or work in any of those places. And this is really a trend that's going to keep going as we see it into this intelligent ecosystem, where pretty much at the end, a lot of these ecosystems right now, environments, they're pretty much connected, right? And if you see a city, it's pretty much that, and this picture shows it, right? There are different, domains, and sometimes they're completely different industries, but really they interconnect, right? If, for example, I might be going from my house into a retail space, and I'm going to go through an urban space, maybe get into a bus, get into a retail store, and sometimes the retailer might want to know actually what's the flow of people that's coming to this retail. Are there people around? And maybe the fact that they're not coming to their store, maybe that's an issue, right? So it's all actually interconnected. If we look at the energy grid, there's a huge push, right, for efficient energy grids right now for sustainability. But really, at the end of the day, the energy grid, connects with the type of infrastructure that's really using the energy, whether those are buildings or other things like even streetlights or EV chargers and so on and so forth. And by connecting, right, all these ecosystems, you can start doing optimization on the grid in a much efficient way. You can create buildings that are grid interactive. You can start creating like infrastructure that are grid interactive and efficient. So we really see, the future of this intelligent ecosystems. And we have a vision as Microsoft for that. And obviously we came out with the Azure Digital Twin product that's really important for enabling this connected environments and in the future, this intelligent ecosystems. So in that sense, digital twins, they start becoming really important. Justin talked about IoT and why that is important in the transformation that's happening. I don't think I want to spend much more time on that today, since I want to focus more on the digital twins aspect. Obviously, AI, maps, and digital twins, right? So digital twins is this key technology trend that's really enabling what we call fusing the physical and the digital, right? By really being able to create a digital replica of everything that's in the physical world and more. So in a way, we've been connecting all these devices and, in general, by being able to connect devices in real time and harness data, right, real-time data, we're able to do a lot of things that was not possible before, or was not possible in an efficient way. So all things from on operations, from remote monitoring to fault detection to predictive maintenance. There are all sorts of things you're able to drive through a digital world back into those devices and in the assets. And so what we see is, at the end of the day, all these devices and assets, they're all in some sort of a space. They're contextualized, whether they are located, whether they're measuring something about that space or environment. And so when you start adding context information to the things, you really start doing additional, you can start getting additional insights and start doing things like occupancy and utilization, for example, in a building. It's one thing to say, hey, the room temperature is increased, or it's beyond certain degree. The other thing is to say, hey, the room temperature in this exact room that's shaped in this way and it's in this building is actually increasing. And so by having all this information about that context, you can start really doing additional create experiences at the end of the day. And ultimately, as part of this things and places, people is that important intersection. So at the end of the day, people are either living, working in the spaces and where the devices are. And so by also bringing, the process in addition to the systems context, you can start creating really awesome experiences. For example, there could be a wayfinding experience in a building according to an exact location of a person and an exact location of a conference room, or wayfinding to the conference room, for example, that's open and not utilized in this moment. So maybe in a summary, before I get to what Azure Digital Twin is and where it's placed, digital twins, there's, it's a key trend, and a digital twin solution is always a data integrator, right? That combines very rich and complex data from different sources and systems in a consistent model. Typical applications, one as a solution integrator and creating integrated experiences. So in a city, whether it's in a building or in campuses, you can imagine that there are a lot of different assets or solutions that are coming into the spaces, and so allows to create an integrated experience across from multiple signals, for example. Often people talk about, hey, we want to have a single pane of glass for doing command and control. I've seen a lot of awesome solutions from our partners, for example, that are harnessing a lot of signals from the urban space, whether those are about traffic, people flow, waste bins, and air quality and others, and actually bring it into a single command and control pane where city officials could take a look and get a pulse of what's happening in that city. And then can also be used for simulation, obviously, one of the main use cases for digital twins. And so this, since it's integrating data from multiple sources, you can store the data, and really this allows to create simulations and models that can allow to track the past and predict the future. And really close with that is, common use of value for digital twins implementations for cities around what if scenario or planning scenarios, whether it's for emergency perspective, but also for planning optimization. So one thing that I keep hearing in different forums, for example, is how do you route urban planners have to make decisions between, hey, do you create a new road completely if there's congestion and there's pollution, versus do you route the traffic in a different way? And if you route traffic in a different way, what's the impact on the air quality in a certain neighborhood, right? So these are all type of possible implementation of digital twins, and especially in for cities. So I said that this digital twin, right, is a data integrator that combines different data from a variety of sources. So in a way, we see that it's there's it starts from, or there is IoT data, right? That's pretty much key and very important at this point. There are a lot of devices that are generating data and new insights. That's all a source of data, and that comes always now in a digital twin solution. And then there's a structure type of information, for example, around being able to understand different entities. If that's, for example, a building, to be able to say, hey, building has a specific topology, and building could have floors, and floors could have room, and so on and so forth. So more of the structure type of information. And this always needs to be up to date and representing the operational state. So just by, in fact, combining the structural information together with the IoT data, you start having a lot of much more richer insight than you would have separately. And then obviously, Justin spoke about Azure Maps, right? Geometry information and data is very important. That's another part of the puzzle when we start creating complete digital twin solutions. And obviously, there are all the 2D, 3D type of design geometry data that maybe also sit in different systems. They could be spatial information with things like spatial anchors for that now we see for augmented reality and mixed reality. And then you see that in the fourth column, I have behavior. And this is really where physical models come to the picture, especially when you start looking at creating digital twins for simulation or solutions that have simulation into them. Obviously, you start adding heuristic models. There could be other things like deep reinforcement, and all this type of data as well becomes another source of data for creating digital twin solutions. Obviously, the notion of time and being able to have historical data is super important. And then there's all the businesses data, right? That traditional line of business systems and platforms actually are holding, and this is also in combination is super important. So from a Microsoft perspective, if you see, we do offer various services from all the services that we have in Azure IoT. So IoT Hub is a main service for ingesting IoT data. Then in the structure, that's where Azure Digital Twin comes. From a geometry perspective, Justin spoke about Azure Maps, and we have spatial anchors. If you look at creating behavioral data or services, solutions around simulation, we have all the cognitive services, that Bonsai service platform. And then if you look at time, really time series insights, data explorer are all services very important for this. And ultimately, if you start looking at connecting business data, we have a whole suite of Power Apps and all the logic app connectors that come as part of this picture. So what happens is that, I want to reiterate what Justin said, right? Like, we are a platform company, we're providing platform pieces. And so our partners that are building solutions, they can take a number of the services according to the solution that they're building and really create their own solution, their digital twin solution. But this shows you that we have a plethora of services that are actually very key for building complete digital twin solutions. So last year in November or December, Azure Digital Twin service became GA, so general available as an Azure service. It's been out in the market for the past 2 years. It started first actually with our efforts in the smart building area, because it was pretty obvious that the building industry was looking for bringing context information and really bringing any sort of the environment notion in addition to the devices. So that's where it came, but it was clear that it was super irrelevant for all the different industries. And so we've been really hard at work to make it available as a platform for anyone really to create any type of digital twin solution that they want to create. And so in Azure Digital Twins basically allows you to model any environment, connect sensors and devices and any business system. And then obviously you can run different things on top of it, computation, and allows you to ultimately control the present or track the past and predict the future in combination with additional past services. So it comes with 4 key components, if you will. The first thing is the open modeling language. I'll talk a bit about that more. It has a live execution environment, then it allows input from IoT data. So it talked about IoT Hub, for example, or any other business system, and it allows output to any Azure service. So whether it's a time series insight to Azure Maps or any other storage option. And then we have a number of digital twin partners that really focus on different aspects of digital twin, whether those are physics simulation or infrastructure, for example, digital twins, and so on and so forth. So what is the open modeling language, right? So we call this digital twin definition language. And it's a key component of really starting to build how you build or model, or how you create a replica of an environment. You pretty much start modeling that. So if I have a building, if I have any other type of space, if I have an energy grid, start modeling what this environment is for all matters. It could be even a process. It could be an abstract environment. So DTDL is open source. We've open sourced it, and it's a rich modeling language that you can describe any twin in terms of the telemetry that they're emitting, the property that they have, the commands that they can be responding to if they respond to any command. Relationship with any other entity, as well as maybe also being able to describe things in such a component way, especially, for example, if you have a phone, camera could be components, and you could start reusing a certain type of definition. So in this little snippet here, in the bottom right, you could see as an example, it's JSON LD based, and so there's a specific ID that describes what a twin is, and pretty much you can start using all the constructs to be able to richly describe what your entity is. Once you've created your entities, you've modeled your environment, the next thing is really to bring that to life, right? So that's where Azure Digital Twins comes as a service. It's a live execution environment, so where you upload this DTDL models, and then you start creating pretty much a graph representation of the environment instance that you have at that point. For example, if you've been modeling a building, it could be your building that has specific rooms, that has specific floors, and all of that gets represented in Azure Digital Twins. Once you have that, obviously now what? You use a rich eventing system to drive any business logic on top of that information. You could, for example, use your custom compute or compute like Azure Functions on top of it and start really driving business logic on top of it. Obviously, once you have a live representation with all the information, you want to query this graph at any time, so support querying in all sorts of possible ways. And then yeah, really you can drive that, whether it's for being able to see exactly what's happening right now at any time, or aggregate informations at any, obviously at a graph level. And then obviously, we say that you need to connect this with some data that's going to keep driving this, your live execution environment. The most obvious thing right now is connected with IoT devices that might be in that environment. And so that's where the connection via IT Hub comes. But then you can also use REST API to really drive it through other business systems or logic apps, if you're familiar with the Azure world. And then output-wise, you could use event routes to send data to any Azure service. If you're familiar and you've built Azure solutions, this starts becoming really easy, and you're going to be already familiar with this paradigm based on other services. But also, so we could be to data services like data lake. It could be Azure Maps, as Justin spoke about, and you can start driving end-to-end solutions through that. So in a nutshell, maybe I just want to show this. Pretty much, this is what would look like from a solution architecture perspective, and we really simplified, how you actually do that, right? So it's not that difficult. You can use the Azure Digital Twin service to get started on your Azure Digital Twins journey and building digital twin solutions that model the real world, which means they're bringing IoT data, you're modeling and bringing a representation of your environment, and then all this data could be leveraged by a number of additional services, whether you want to do simulation on top of it, whether you want to do visualization and location tracking through Azure Maps and other services. All right, so as an example, right, and use case example, since I say that a lot of times buildings, this really shows you, one use case about building. And let's say that in this case, we're interested from a business perspective to measure occupancy and utilization in a building. And our goals are, we want to measure occupancy of conference rooms in an office building. Obviously, we want to drive better utilization of the spaces with real-time occupancy information, or we want to better plan the spaces in a building based also on occupancy patterns. So what you really start doing is, let's say you've modeled the building with DTDL, then you create that live instance in Azure Digital Twins. And so in this example, I have a building, building 1, that has 2 floors, floor 1A and floor 1B that are in the building. And then each floor, there are different rooms. By the way, I have a room that's also somehow in 2 floors. And then you see at the end of each room, there are different devices and sensors that I'm actually connecting to the rooms that I'm interested to monitor certain real-time information. And so you see one of them is around motion sensor, a device that's measuring motion sensor. So anytime that there's motion in the room, I want to know that information. It could be air quality in that specific room, as well as it could be the count, not just that there's motion, but it could be how many people might be in that room. And so with this model, I'm able right now to attach what each of these devices are bringing as data and really provide it as property to the rooms themselves. So you can see that for example, in each room, I have certain properties that they are trying to measure the foot traffic count, people count, or occupancy. So this is how I'm able to drive the specific information in real time. And then I mentioned you can do all sorts of compute on top of the live execution environment. So for example, I might be interested to roll up occupancy information at the floor level. So while I can start doing it once I have it in my room or this leaf nodes, I can actually start creating specific compute functions that allow me to also populate the different properties that I have at any level in the graph. So then once I have this information, right, I can query this at any time to say, hey, is room occupied? Which rooms are occupied, right? Or is room 112 occupied? I can start saying, hey, what is the occupancy ratio of building 1, and actually start seeing that pattern. So one of the typical example for conference rooms, for example, in office spaces, is that, I could book a conference room, but I might not be using it in reality. And I've done that so many times as well, where you think you're going to have a meeting, you book it. This is pre-COVID time. And then you don't use it, but you didn't release the room. So by being able to now having the information about the building, the conference rooms, as well as real-time information, all represented in this live execution environment, you could actually have business logic that says, well, if an occupied room or booked room is not occupied within 15 minutes, you should release the room so others can use it, right? So you start driving all this planning and better utilizations about it on top of this. So this is just one typical example in the case of the building. And then you bring things like, obviously, Azure Maps, and so this is Azure Maps Creator, as Justin mentioned. You can start visualizing, right, this information overlaid on a map. In this case, on a map of a building. And then you can start looking at a glance. What is the occupancy? You can also track what's air quality and what's other parameters, right? So this is how we're bringing together the power of Azure Digital Twins and Azure Maps as an example. We have, probably you can see the story, this is being used in reality, in real life scenarios. Willow is a partner of ours, which has a digital twins for building called Willow Twin. And pretty much that's what they're doing. They're leveraging Azure Digital Twins, all the Azure services, Azure IT, to really drive different, smart building scenarios. And so actually one of the recent deployment of this is a building owned by Brookfield in Manhattan West. It's a flagship building with 67 floors. And so we will probably drop the link to see if you can see that video. And so it really helps, envisioning as well what's really possible and what someone like Willow is able to do, and someone like a property owner like Brookfield is able to get now because of all this type of information. So next, I think I want to spend a few time to talk about DTDL ontology. I said that in Azure Digital Twins, everything starts with you being able to model what that environment looks like. And so one of the key things for us was, you can model a building, you can model a city space, you can model an energy grid or retail space. We can bring standards to express them in DTDL, so partners can really leverage that, and they don't have to reinvent all the time their own definition. One, they can reuse them. There are already standards how to define a building, or how to define, I don't know, an energy grid or a mobility network, and so on and so forth. But then one thing that we've looked at is if we start looking at domains like buildings, campuses, cities, there are a lot of partners, right, that are bringing different type of solutions. So how do you enable actually interoperability with an ecosystem of partners to be able to provide data to a digital twin solution, for example, right? They all have to be able to talk the same language in a way. So we started this effort around this DTDL ontologies, where for different domains, we're evaluating industry standards that already exist. We're not trying to create any standard. And then we work with our partners that are experts in the standard, and they can actually apply them and express them in DTDL. And we've also been very focused on that the standard should be use case driven, that they can be actually used in real life, right? So we didn't necessarily want to be just in standards or kind of more an academia perspective. It was more of applied perspective on it. And then important for us to make them open source, make them available to anyone to contribute and to use through a GitHub repo. We're part of the Digital Twin Consortium as well. That's really driving what digital twins means to the market. And so we're working really closely through that consortium. Over the past few months, we've published 3 open source ontologies, one focused on smart buildings. For this case, we worked and based this work on a standard and a partner called Real Estate Core. So we've adopted that in DTDL. So I have the links here. The other one, we worked on smart cities, and really we leverage the NGSILD models, especially the smart data model initiatives that are funded by Fireware and other communities like the TM Forum. And then we also published one for Energy Grid that's based on the same ontology. So if you want to learn more about each of this anyway, these are the links and you can go and look at them. There are also videos, and you can reach out to us based on, and they're also open for contribution for anyone that wants to contribute. So I'm going to spend 5 more minutes on this smart city ontology. I know I might be running out of time actually. But I'll go ahead until Mutu stops me. For smart city ontology, you will find it in the documentation, but I want to give you an idea of what it contains. Obviously, smart cities kind of different, could be very big and large. So for us, it was important to focus on the type of use cases that we saw are relevant from an IoT perspective, especially. So, there's a lot of smart city use cases around smart parking, smart streetlights, mobility, being able to measure flows of people, crowd, and traffic, etc. But also environmental condition like air quality, weather, or noise, and so on and so forth. So that's also why we decided to look at the NGSILD models. And especially start by leveraging the models that existed under the smart data models initiatives by Fireware. And then in conjunction with that, we also leverage other standards like ETSI, SARA for City to actually bring other type of modeling, for example, that were important around being able to represent any spatial object within a city or in administration area. So this is what once you browse to our GitHub repo, you will find all this type of models, but we're still welcoming partners and anyone actually from communities to help us extend this and to be able to drive various use cases. One of the use cases that I wanted to highlight here, which is important for us to see, is the notion of streetlights, right? That I mentioned that a couple of times probably, what you can do with streetlights and making them smart with IoT. But one thing that we see is that different cities, obviously they're adding smartness to the streetlights, so it becomes an intelligent asset, right? There's a huge energy savings, so it makes sense. It's almost on all cities globally, majority, they have a modernization program for this. As they're doing this, they attach sensors and controls on top of them. There's additional energy savings. But then what we start seeing as a trend is that this poles, they're starting to become a platform for housing different of these devices, IoT devices, that we're seeing in the urban space, whether, hey, they're for air quality monitoring, whether they are for image sensing, whether like people counting, could be traffic counting, anything, whether they are, in some cases, we see EV chargers even being attached to this pole. So we see that trend happening. And so one of the things I said was, hey, so if now that we have these models, from a various standards, how do we actually model something like this? For how much it looked like easy, it was actually complex. It's almost like thinking, oh, there's a building. It's just the difference is there are not people inside this real estate assets, right? And so we were like, how do we bring this to life? And so with the models that we've had, We started actually, when we look at the NGSI-LD, it was good because it gave us a lot of models around how do you describe streetlights with all the type of information that we might have. I spoke about the environmental sensing, like air quality, noise, and all those sorts of observed entities. You can look at, there are things like crowd flow observed or traffic flow observed. And so we're like, okay, this is good, but how do we create a structure that's a pole? So we extended this to create something like a pole that for us it's that key structure, and then we actually combine this with this other standard, SC for city, that actually has a great representation of a city object model. So that's something called street furniture in that, and a pole is a street furniture ultimately. And then really this Etsy for Sarf also uses GeoSparkle to be able to grasp anything in a topology model. So this is where all the spatial elements start to come. So in a way, we were able to leverage various standards, put it together, and see how this actually work for something like a pole. So we realized, okay, we could use those constructs for any sorts of infrastructure that would be in a city or any street furniture. So probably I want to show you really quick because Mutu hasn't stopped me yet. In a way, I hope I have a little time still. I wanted to give you this example. You'll be able to, by the way, quickly do it yourself as well. I will leave you all the links for this. But what I'm showing here is the Azure Digital Twins Explorer. So I wanted to show you okay, there's Azure Digital Twins. I spoke about ontologies. I spoke about the smart city ontology. How do I bring all these things together, right? So obviously, if you go to the smart city ontology in this case, and then we have also the buildings and energy grid, they're all open. You could, browse through it, and understand, actually look at all the type of models and entities that are here. You can actually download it if you want in a Visual Studio Code and see all the type of elements, even if you want to extend it in this way. And then what I did here is with this Explorer called Azure Digital Twins, I have already an Azure Digital Twins instance. And this tool allows me to upload all the models that I have. So in this case, on this left side, you see a list of a number of models. And these are actually exactly the models that I have in this repo. So I uploaded them here. Now, once I have these models, and actually before here, I'm gonna click on this twin graph. And I wanna show you, if my link is working. Oh, model graph, sorry. Pretty much this starts showing me actually all my entities, and it's cool. I can also see all the relationships that I have with this entity. So you can start understanding how these models are formed. I'm starting to increase this. I want to show you. So for example, you see that I have a pole model here that has a relationship with EV charging, has a relationship with air quality or street light, and so on and so forth, has a relationship with districts. So you can really see how your model really is connected. And then what you can start doing in Azure Digital Twins then is really creating live execution environments, so a live instance of anything that you want to bring. So in this case, in my case, this is an example. I created a city, Bellevue, and I've used all the models here. Let's say that I have 2 districts in this, and I'm interested to actually have a smart pole application, and then I want to use the smart poles to measure and acquire a lot of signals around a lot of environmental sensing and others. So you see here that I have different entities like poles. Each pole, for example, has a streetlight component to it. And as I click on this entity, you see that using this Azure Digital Twin Explorer, I can actually navigate and see what are all the properties that this entity has, in this case, streetlight. You can see that there are a lot of streetlight related information, like when was the lamp changed and so on and so forth. It could be air quality observed. In this case, you can see that I have information about anything that's relevant from an air quality perspective that's described according to the model here. And I can also use to start creating additional entities. So I can instantiate another one. Let's say I want to have my pole 2. I can use this to quickly create things. And so my pole 2 is here. And so I might want to say, hey, this pole 2 is going to be in district 1. So I can create with this, I can create a relationship, and I can say, hey, the pole is within the district. Can save it, and then I can start also adding information about this, and I can continue to associate it. So on top of this, then you can actually query this using this Azure Digital Twins Explorer. You can do various things on top of it. So it's a very quick way also for you to kind of try it out, get started, and have a feel of like, oh, what are the all things that you can do with these Azure Digital Twins using this Azure Digital Twin Explorer. I mean, we could go on and on with this smart pole example. It's one of my favorite topics, but since we are probably out of time, I want to leave you with the resources. I know Mutu will post them as well. But to learn more about, anyway, this urban environments and what's the role of IoT, maps, and digital twins, we have a blog on that. You can read that. Then we have a blog on the smart city ontology. You can also see who are all the contributors and partners that worked with us on this. And then for Azure Digital Twins, I actually recommend you to look at this IoT show, and so you can have a longer version of the demo that I was trying to do. With that, you can find me on LinkedIn or on Twitter. These are my contact information. It's been a pleasure, and probably I took more time than what I was supposed to do. If you have any questions, I don't know if we have time. Otherwise, I'm happy to get to that later.